Guys, we are starting the last section of Module 11 today, which is 11.3. This is solving radical and rational equations. We will also be checking for extraneous. Today I am just going to concentrate on the radical or the rational exponents that start with a square root. I will pick up with the cube root, the fourth root, and any other roots on Thursday's lesson. So today I'm just going to kind of small sample some of these. We're going to do questions 1, 2, number 4 down here. You can't see because it got stamped out. Number 6, number 7, and then on the back question number 11. I think I spaced these out a little bit different for you guys. Off to the side, I'm also going to be writing the steps, so it might be in your best interest to write those down as well, kind of as I go through them. So all of the questions that we're doing, again, have square roots in them. Therefore, it kind of keeps it to the same type of process before we mix the different types together. So step number 1 is going to be to isolate the radical. And I'm going to leave these very general because we're going to use these same steps when we solve all of these equations. So question number 1, or step 1 for question number 1 is isolate the radical. So what that means is it needs to be on a side by itself. And I'm going to zoom in a little bit here so you can kind of see the question as well. So to isolate the radical for question number 1, I'm just adding the 1 to the other side. So you're still sticking with your algebra solving equations. It's just going to look a little different. Step number 2 is you're going to raise both sides of the equation to the reciprocal root. So raise both sides of the equation to the reciprocal power. So the reciprocal power is, if that is a square root, to get rid of the square root, you have to square both sides. And when you square both sides, what happens on the left side is these radicals cancel each other. So then I have what's left underneath. Now technically I could throw some parentheses around there just because both things stay together. But I really don't need them there. So I squared the left side, it cancels my radical. And then I'm going to square the right side, and 8 squared is 64. Next step, step number 3, is probably one of the easier ones on this type of question anyways. Step 3, you're just solving for x. So sometimes you're going to be solving a linear, sometimes you're going to be solving a quadratic, sometimes you're going to be solving a cubic. So it really just depends on what kind of root or how your answer comes out or how your equation comes out after you get rid of your root. So this is a nice linear, so I'm going to subtract 4, and I'm going to get 3x equals 60, divided by 3, x equals 20 is my answer. But because you have a square root, so any even root, you have to check for extraneous solutions, especially with your even roots, because even roots have to equal a positive answer only. And I'm not saying that you can't get a negative number, but when you're taking the square root, you cannot take the square root of a negative. It has to be the square root of a positive. So when you're done, this number underneath can only be a positive. So I'm going to check this real quick, and you have to do the check. It's not an option. And the check is just you ensuring that the answer that you actually got is the correct one. The check shouldn't take up much time or room, as long as I write small enough, that is. So when I check my answer, I'm going back to my original equation and just plugging 20 in. So 3 times 20 plus 4 minus 1 equals 7. So 3 times 20 would be 60. 60 plus 4 would be 64. The square root of 64 is 8, and 8 minus 1 is 7, and there's my check. You can use a calculator when you do this, but you have to show each step. You have to show your check. It's going to be worth 1 point. So It's not, like I said, something that you can sometimes do. You have to do with all answers that you get, especially with the even roots. Okay, so that was a nice linear equation. I'm going to go to question number 2 because question number 2 is also a square root. So I'm going to isolate the radical. So I have 2 radicals in this question. I have a radical here and then I have a radical here. So all I'm going to do is add the entire radical. They have to stay together. And I'm going to add it to the left side and I'm going to add it to the right side. Squeeze it in there. So when I add it to the right side, then I isolate my square root of 2x minus 5. And then on the right side, I have x plus 3. You can't separate the 2x minus 5 and you can't separate the x plus 3. Those are binomials together underneath. And then now that I have it isolated, so I have one radical on the left, one radical on the right, step 1 is done. I'm going to raise both sides to the reciprocal root. So the reciprocal root of the square root is squaring both sides. Once I square the square root on the left side, they cancel, and I'm just left with 2x minus 5. When I square the square root on the right side, they cancel, and I'm just left with x plus 3. So now I'm solving for x. So now I'm going to, again, this is a nice, easy, linear one. I'm going to solve my algebraic equation here. And I get x equals 8. Step number 4, I forgot to write last time, you have to check for extraneous solutions. Extra, wrong solutions. Especially if you have an even root. Because even roots, you can only take the square root, or the 4th root, or the 6th root of a positive number. So it has to be a positive number underneath. Alright, so now I'm going to check x equals 8, and I'm going back to my original equation. So check x equals 8. Up to the top here, I'm going to get 2 times 8, which is 16. 16 minus 5 is square root of 9. Nope. How about 11? Square root of 11. There we go. I was hoping it came out to a nice number, but not so much. And then again, so I'm going here. I'm not going to the one that I solved. I'm going back to the original. Then I have square root of x plus 3, so 8 plus 3. And 8 plus 3 is 11. Square root of 11 minus 11 is 0. And my original equation had it equal to 0. So equals 0, equals 0, equals 0. So that does check. It doesn't matter what the square root of 11 is, because square root of 11 is not our answer. That just comes what is the result of us checking our answer. So x equals 8 is another good answer. Next question that has the radical of square root only. Question number 4. You can see in question number 4, it also looks different. So the first one had 1 radical, the second one had 2 radicals, this one has 1 radical, but on the left side, it's not just a number. So I have to throw parentheses around this left side because it is a binomial together. So it's already isolated, so step number 1 is done because it's by itself. So now I'm going to raise it to the power, and the reciprocal power of square root is squared. Now, unfortunately, when I do x minus 4 squared, that means it's x minus 4 times x minus 4, which means that I'm going to have to FOIL this. So right here, right now, I'm going to FOIL. So I would get x squared I would get minus 4x, so minus 8x. Negative 4 times negative 4 is 16. Okay, so now I have a quadratic, and my quadratic has to be set equal to 0 because it's a quadratic. So I'm going to subtract 2x. So I have x squared minus 10x plus 16 equals 0. Now because this is a quadratic, I'm either going to have to factor or do the quadratic formula. So this step here I'm factoring. Factors of 16 are 4 and 4 or 2 and 8. The two that I'm looking for add to be negative 10, so I'm going to pick 2 and 8. My middle sign is a negative, my last sign is a positive, so this is going to be a minus minus. And then I'm just going to solve. So I get x minus 2 equals 0, x equals 2. I get x minus 8 equals 0, so x equals 8. So those are my two solutions. But are they really? Now I have to check for extraneous solutions. So down here, I'm going to make this box a little bit bigger because I have two solutions that I have to check this time. So I'm going to check x equals 2 first. I'm going back to my original equation, and I have 2 minus 4 equals the square root of 2 times 2. Square root of 2 times 2 is square root of 4. Square root of 4 cannot be a negative. So this does not check out. So I kick out my x equals 2 because it's an extraneous solution. Second, I have to check my answer of x equals 8. If neither one of these answers work, then I just put no real solution, but hopefully one of the two, if not both of them, would work. So again, I'm going back up to my original equation. My original equation says x minus 4, so 8 minus 4. On the right side, I have the radical square root of 2 times 8. 2 times 8 is 16. Square root of 16 is 4, so that one checks. So my only answer is x equals 8. Again, sometimes it's going to be one answer, sometimes two, sometimes neither one of them. Okay, the next question I'm going to do is number 6. Number 6 also has two radicals in it, square roots. So this kind of looks like question number 2 when I had a radical subtracting another radical. So this time I'm going to isolate my square root by adding it to the left and right side. So I get square root of 3x plus 2 equals 2 square root of x. So I isolate square root on the left, square root on the right. Step number 2, I'm going to start to pick up my pace here a little bit. Square the left side, square the right side. When I square the left side, those cancel, and I'm left with 3x plus 2. This time when I square, there's a number on the outside, so I do have to square the 2 and square the square root. So 2 squared is 4. Square root of x squared is just x. So you have to do the number and the radical. Now I'm just going to solve. I have a nice linear equation again, which I like. I'm going to subtract 3x from the left side and the right side, and I get x equals 2. But I have to check, and I have to check because it's a square root, and that means that I'm not guaranteed that it's an actual answer. So check x equals 2. Going back to my original equation, 3 times 2 is 6, 6 plus 2 is 8. Square root of 8 does simplify. The square root of 8 breaks down, and you have it on your square root sheet. The square root of 8 is 4 times 2, so 2 square roots of 2 would be square root of 8. Then I'm going back to my original equation, and I'm subtracting 2 square roots of 2. 2 square roots of 2, because that's underneath there. Just writing down the rest of my check here. 2 square root of 2 minus 2 square root of 2 is 0. Therefore, I do know that it checks because 0 does equal 0. So all is well with number 6. So my answer is x equals 2 because it did check out. All right, next question is number 7. Number 7 looks a lot like number 4 that I did up there, where I'm going to have to square the left side, square the right side, and it's going to be a quadratic. So it's already isolated. Step number 1 is done. I'm going to put some parentheses around my x plus 2 because it is a binomial. To clear the square root, I'm squaring the left side, squaring the right side. When I square the right side, my square and square root cancel, and I'm just left with 2x plus 28. But for number 7, when I square the left side, I have to FOIL. Some of you guys might remember the pattern, but if not, you're just going to have to multiply it out. So this would be x times x, x times 2, 2 times x, so 2x and 2x would make 4x, and then 2 times 2 would be 4. Okay, I have a quadratic, so it has to be set equal to 0. So I'm going to subtract 2x, and I'm going to subtract 28. gone, gone, so it's equal to 0, which means that I'm probably looking at some sort of factoring here. So 4x minus 2x is 2x. 4 minus 28 is negative 24. Now we're going to factor. Multiplies to be negative 24, that adds to be 2. So 24 would be 2 and 12, 3 and 8, 4, and 6. Signs are going to be 1 plus, 1 minus because I have a negative. The bigger number is going to be the plus, smaller number is going to be the minus. And now I'm going to solve. So I have, run out of space. So I get x minus 4 equals 0, which is x equals 4, and x plus 6 equals 0, which is negative 6. Okay, but I have to check. And I did create more space for you guys. I put this on the back, so you'll have more space than I did. But for right now, I'm just going to do my check on my sticky note, or I could have done it on my notebook paper. Okay, so check. My first one that I got is x equals 4, going back to my original equation. 4 plus 2 is 6 on the left side of my original equation. Right side is 2 times 4, which is 8, and 8 plus 28. 8 plus 28 is the square root of 36, and the square root of 36 is 6, so that one does check. So my answer of x equals 4 is good. Next answer I got is x equals negative 6. Now, just because this is a negative answer doesn't mean that it's not going to work. However, chances are it probably will not just because it's a negative. Back to my original equation, negative 6 plus 2 is negative 4. Right there I start to recognize, okay, it's a negative number, and I really cannot get a negative number out of a square root, so chances are this is not going to work. So 2 times negative 6 is negative 12. Negative 12 plus 28. Running out of room here. And negative 12 and 28 make the square root of 16. Square root of 16 cannot be a negative number. Now the reason this cannot be a negative number is because you're not solving here. You're just simply plugging in a number and checking it out. So this does not come out to be equal, which means that negative 6 cannot be an answer. So your only true answer is x equals 4. Okay, I'm going to leave one for you guys to try on your own, and this we will do during the Zoom. I am leaving question number 11 for you guys to do on your own. And this will be due Tuesday during the Zoom. Okay, so we'll do this one together, and then any other questions that you have on Tuesday during the Zoom. Take care, guys. I miss you all.